So I wanted to talk about this. This is a talk that is based on a talk that I saw a couple of years ago at DDD. So it's basically using Git to kind of automatically find. I put on fixing bugs. It's sort of fixing bugs. It's more the situation where something's been introduced into your code base. It worked before, and you want to find out what changed it. So the subtitle is automatically assigning blame. I just wanted to put an attribution here. The person who gave the talk is a guy called Luke Stringer, and I put a link to his talk. So his talk is kind of the manual process, although he does allude to the fact that you can do this automatically as well. I'll put a link to that in the chat if someone reminds me later. So basically, in Git, you can do a binary chop to determine where something's changed. So it basically says, tell me what's good, what's bad, and then I'll tell you where it changed from one to the other. And it does it in the same way as, if you can remember back when you were a kid, and you'd say, if you pick a number between 1 and 100 and tell me whether or not my guess is higher or lower, I'll be able to guess it in 7 goes. And it's that kind of process. So there's no magic. It just says on the manual process, it just says I've checked out this version of the code. Is it good or bad? And you tell it one or the other, and then it just divides the remainder in half. So as is typical with me, I've done a little bit of a PowerPoint presentation. So you start off by, you say, git bisect start, and this sort of establishes that you want to start bisecting your code, and then you'll tell it what's bad, and it'll say, okay, well, I know that the change is in kind of one half of the code or whatever. In that case, you've not told it what's bad, so it just assumes that what you've got at a minute is bad. And then you tell it what's good, so you give it a change number. And then based on that, you kind of carry on with these processes, and it'll go, okay, there's your breaking change. I've just found your breaking change for you. So what I found was that, well, I didn't exactly find this. It was in that video, but what I've long wanted to do was to determine how to automate this process, because it's useful if you do it manually, but it's amazingly useful if you kind of automate it. So the situation here is, you've got three possible ways of automating it, or probably more than three, but three that I'm going to cover in this talk. So the first one is, you've got a unit test that covers the functionality you're interested in, and it's broken, and nobody ran the unit test when they checked the code in, and now you want to determine where that test broke. The other situation is and this is probably more likely, because in the first situation you could probably just look at the check-in history and see which one had a breaking test. The second situation is you've worked out some functionality changed, and you can create a unit test for it, and that will tell you where the breaking change was. And the third one is, you can pretty much kind of plug anything you want into this. So I've given the example of a console app here, where you can determine the breaking change. That console app doesn't have to do what it does in this app. That console app can go out and do a performance test or something. So you wanted to test when your performance has slowed down, then maybe you could write a console app that went off and did that, or I don't know, invoke JMeter, or one of a myriad of different things. So I've got a sample app in. I'm not going to do any live demos because it's a 15-minute talk, and they always take longer. But essentially, what I've got is a demo. I've got an engine that basically adds two numbers together, or does a calculation on two numbers. and then just output something. And I've sort of made it vaguely unit testable. The code for this is on GitHub, so feel free to have a look. So the first situation where unit tests are broken. So I've got a unit test here. It was working fine, and then it stops. This obviously it's worth remembering that what git bisect does is it checks out versions of the code. So if your unit test is broken, that's a unit test that is in your code base and was in your code base when it broke. So if that unit test is changed, then obviously when you check your code base out, that'll change as well. So in this situation, it's a similar sort of process. So you issue a git bisect start. You tell it that your current situation is bad, and you tell it where the good one is. And then you basically just tell it to run, and you pass it the test. So you just go git bisect run .NET test, and then you give it where the test is, and that will go off, and it will say, okay, the current commit is bad. This commit here is good. I know that, so I'll divide it in half. I'll check out that commit halfway. I'll run this test on it. Did that test pass or fail? If it fails, then it's bad. If it passes, then it's good. So and then do the same thing. So the remaining section of the code, is it bad? Is it good? So on and so forth. And then eventually you'll get something like this, which will say, I know that's a bit small, but it says, this particular commit is the first bad commit. But like I said, that's probably not the more interesting one, because the likelihood is you'll be able to track that down a lot faster. So the more interesting one, or at least the second most interesting one, is where you create a new test. So obviously, like I said here, the important thing is you don't check it in your code base, because when it checks it out, it'll take the test with it, and you can filter for a specific test. So we've got a new test here. It's not checked into the code base, and what you do is same sort of process. Start bad, good. But this time, what you do is you run the test, but you give it a filter. So you basically filter that new test, and it'll only run that new test. Then that's not a feature of Git Bisect. That's a feature of .NET Test. But that just means that you can basically say, okay, I've got this new test. I've not checked in a code base, but it will determine where the code's broken, and that'll again go off, do the same thing. It'll just check it all out, and then at the point where it determines that your code's broken, it'll say, okay, that's where your code broke. And then finally, and I think this is the most interesting, is that you can write anything that returns an integer and pass that to Git Bisect. So here I've got a console app. So all I've really done here is I've done .NET new console. I've changed void to int, so it returns an integer, and I've got a test here. So this can be anything. I mean, like I said, you could call an API here, like Kev's going to demonstrate API testing later. You could do a performance test here. You could do all kinds of things, and then you just return a value that you decide determines success or failure, and that's kind of up to you. 0 being success. And then to run that, it's really simple. So same sort of thing, start bad, good. And then you basically say, okay, Git Bisect run, and then you give it a link to the app. The one thing that's worth bearing in mind, this is a .NET console app, so you might get some problems if you have a framework dependent app rather than I don't know if that's the correct term, framework dependent, but you want a kind of self executable rather than one that's dependent on the framework. But other than that, it'll just kind of go off and merrily run the app. every time you check something out, so it could take a while. And then it'll return success or failure, and then it'll tell you where your code's broken. And I think that's me.